Okay, let's move on in our review here as we're looking at conversion of polar coordinates to rectangular coordinates. So we just finished converting some rectangular coordinates, some ordered pairs x, y, over to polar coordinates, coordinates of r and theta, our radial coordinate r, and our angular coordinate theta. So let's see if we can find the exact coordinates for this conversion from the point -4, negative pi over 3. So first thing I want to do, let's go ahead and get a quick picture of this point. Let's go ahead and plot the point. So where is it located? So remember, as we're doing polar coordinates, we go with our pole here at the origin. So here's the pole. All right, now our polar axis, the positive side of the x-axis. Here's the polar axis. As we rotate, there's r and theta. So theta is negative pi over 3. So we got a clockwise rotation. And negative pi over 3, right, is negative 60 degrees. So as we go theta equaling negative pi over 3, right here is where we are with this rotation. Now we have a radial coordinate of -4. So that means we got to go the opposite direction. So that means we're going to go to the 60 degree mark, right, or pi over 3 radians, here in quadrant 2. So let's go ahead and mark out -1, -2, -3, and -4. So there's our distance there again of 4. So we've got our point now that we can plot -4, negative pi over 3. So again, remember we go the opposite direction. Now as we're looking to convert, we're going to convert over, of course, to rectangular. So we want to look at the horizontal and the vertical distance, all right, that's traveled to that point. So we want to find x and y. And to do that, as we talk about theta here, and again, theta in this point quadrant here, this is our 60 degree mark. This is 2 pi over 3, right? Or if you look at the reference angle, this is a pi over 3 angle. This is a 60 degree angle, right? Or pi over 3. So with that said, let's go ahead and talk about finding x and y. So we're looking at a right triangle. So what definitions could we involve in finding it? Well, we know that the cosine of angle theta equals x coordinate divided by radius, right? So again, we've got our radius r. So again, r is equal to -4. In this problem, we went 4 units that way. All right, there's our radial coordinate. Now, with that said, again, adjacent over hypotenuse, and you can see there in your drawing, which derives x coordinate over radius. We define cosine of angle theta, all right, using our rotations, using that point there on the terminal side. With that said, we want to find x. So to find x, let's go ahead and rewrite this. We'll go ahead and solve for x by multiplying both sides by r. So as we do that, we come up with x equal to r cosine of theta. So here's our conversion formula. So radius times the cosine of theta. So our radius is -4 times the cosine of angle theta, and the cosine of angle theta is negative pi over 3. So we'll go ahead and put in the angle that was given. That was theta there. And we all know, based off our special angles, at negative pi over 3, if you want to, we can talk about our unit circle. Right, at negative pi over 3, at negative 6 degrees, we have a x coordinate of 1/2, and we have a y coordinate of negative square root of 3 over 2. So what is cosine's value? So we know that the cosine of negative pi over 3, right, cosine negative pi over 3 is equal to 1/2, right? It's equal to the x coordinate. So over here we got -4 times 1/2, which is what? -2. So what does x equal? X is equal to -2. So now we need to find the y coordinate. So how are we going to find the y coordinate? So let's go back to our definitions. We know that sine of angle theta is equal to y coordinate divided by radius, right? Opposite of hypotenuse, you can see there in our drawing. As we solve that for y, right, we'll get our conversion formula. So we multiply both sides by r. to solve for y. And we come up with our conversion formula here. We come up with y equal to r sine theta. So x always equals r cosine theta, and we know y always equals r times sine theta. So we got our radius, which is -4, times the sine of theta times the sine of negative pi over 3. And we know from the unit circle, sine's evaluated by the y-coordinate, so it'll be -4 times negative square root of 3 over 2. And as we simplify that, let's go ahead and reduce. We get -2 times negative square root of 3, which is 2 square roots of 3. Right, as we look at that. So there's our y-coordinate, right? So we got our y-coordinate now. So y is equal to 2 square roots of 3. So as we're looking at our conversion, right, we've got our point now. So we've gone from, what, polar coordinates. Now we've got the rectangular coordinates. So this is equal to x, y, x being -2, and y being 2 square roots of 3. So there's the rectangular coordinates. All right. So again, we're given r and theta. We've got x and y back. All right, let's do the same thing with our next one. And then this one we got number 9. We've got -12 and 45 degrees. So let's take a look at it. We'll draw a quick picture here to see what we have in front of us. All right, now we know in a rotation of 45 degrees, we rotated here 45. There's theta right here in the middle of quad 1. And again, -12, right? We're going to go opposite direction. -12 radians. So that'll put us down here in quad 4, right? There's -12, 45 degrees. So we need to find the x and y coordinate for that point here in quadrant 3. So let's go ahead and look at the horizontal and vertical distance. Look at x and y. So again, we've established, right, that x, we've got our formula. We know x equals r cosine theta. So x is equal to -12 times the cosine of 45 degrees. And we know the cosine of 45 degrees is square root of 2 over 2, right? We can look at our unit circle. X coordinate, right on the unit circle, right, is 45 degrees. As we simplify that, of course, 2 divided by 12 6 times, we get -6 square root of 2, right, which is our x coordinate for that point. So again, as we simplify that down, now let's find the y coordinate. So what will y equal? Y is equal to r times the sine of theta. So y is equal to radius, which again is -12, times the sine of 45 degrees. And the sine of 45 degrees, just like cosine, holds the value square root of 2 over 2, one of our special angles. As we simplify, we'll get -6 square roots of 2. So there's our y coordinate. So what is this equal to in terms of rectangular? We got -6 square roots of 2 and -6 square roots of 2. There's x, right, and there's y. So again, you can see your conversion, right? We begin looking at our polar coordinates and converting back here. All right, let's go to equations. So as we look at equations, here we've got some rectangular equations. Y squared equals 16x. We want to convert it to r and theta. So remember, what does x equal? So we know x equals r cosine theta. And we know that y equals r sine theta. So based off that, as we plug that in, y squared, that would be r sine theta squared, equal to 16 times x, 16 times r cosine theta. So we get what? R squared sine squared theta equal to 16r cosine theta. All right, let's go ahead and write that in, 16r cosine theta. Now, one thing I want to do with this, I want to try to get it in graphing form. So I always like to get it in r equal form. What I'm going to do, let's go ahead and divide out the common factor of r on both sides. Let's go ahead and simplify here a little bit. Let's do that. We get r here. So that implies our equation now, which is in polar form. We have r sine squared theta equal to what? 16 cosine theta. So we divide out the r on both sides. And now we can go ahead and solve for r. We want to get it in what we call graphing form. All right, we can divide out on both sides the sine squared theta. And with that, we got what r equals. R is equal to 16 cosine theta divided by sine squared theta. So there's our polar equation, right? Looking at it again, graphing form, r equal form. But again, remember our conversions. X is equal to r cosine theta, y equal r sine theta. So let's do the same thing at 11. So we just got done with a parabola, right? Y squared equals 16x, equation of a parabola. Looked at it in polar form. And you could graph that and you calculated to see a graph of that parabola. And we got a hyperbola in this next equation, x squared minus y squared equals 4 in a rectangular. Let's convert it over. So r cosine theta, right, is equal to x. So we got r cosine theta squared minus r sine theta squared equal 4. So we let x and y equal r cosine theta and r sine theta respectively. As we simplify, I got r squared cosine squared theta minus r squared sine squared theta equal to 4. And then let's work on, again, getting in graphing form. We got a GCF, a greatest common factor of r squared. Let's go ahead and bring that out. As we do that, we get cosine squared theta minus sine squared theta equal to 4. And if you notice, that's an identity. So if you remember back to identities, this is our double angle identity. So we can actually simplify this nicely. So our double angle identity here in front of us. So again, reviewing back to identities. I know that the cosine of 2 theta equals cosine squared theta minus sine squared theta on the double angle identity. So we can go ahead and replace that with cosine 2 theta. So this implies r squared times the cosine of 2 theta equal 4. All right. So again, we're trying to simplify a little bit, get in graphing form. And again, you could take and divide out the cosine 2 theta on both sides, right? You want to solve for r squared. R squared equal 4 divided by cosine 2 theta. But just converting it over, getting it in polar form, right? Using, again, some identities to simplify down a little bit with both sides, right? And you could take the square root of both sides to get your radius, r equal. But we'll stop there with that one. Let's go to converting rectangular equations. Now, in rectangular equations, we need x and y. So right now, we've got everything in terms of r and theta. So let's remember now our conversion definitions. We learned today that a radius is equal to the square root of x squared plus y squared, right? We showed that with Pythagorean theorem earlier. We were converting, right, from polar coordinates to rectangular coordinates, right, or vice versa, given rectangular back to the radius and the theta value. So with that, we know that definition. And of course, we also know that cosine of theta in terms of x is x coordinate divided by radius, which is equal to x over the square root of x squared plus y squared. So cosine theta in terms of x and y, we've got its definition. And same thing goes for sine. Sine is y coordinate over radius, which is equal to y over the square root of x squared plus y squared. So there's our conversions, right, as we're looking at going from r and theta over to x and y. So to our equation, r, which is square root of x squared plus y squared, minus 5 cosine theta, which is 5 times x divided by the square root of x squared plus y squared, equal to 4 times sine theta, which is y divided by the square root of x squared plus y squared. And let's go ahead and clear out the fraction. Let's simplify this a little bit. Let's go ahead and multiply by the square root of x squared plus y squared as we clear out these fractions and simplify our equation down. And as we do that, of course, here we're creating a square, right? So this equals x squared plus y squared. All right, minus, again, these divide out, so that's minus 5x. These divide out, so that's equal to 4y. So again, multiplying by the LCD. And with that, you got your rectangle equation. X squared minus 5x plus y squared minus 4y equal to 0. So there's our rectangular equation, right? Let's go do the same thing with 13. 13, I've got theta equal 2 pi over 3. Well, what do we know about theta? We know the tangent of theta equals y coordinate over x coordinate, right? So there's our conversion over to rectangular. So that implies the tangent of 2 pi over 3 equals y divided by x. And what is the tangent of 2 pi over 3? Right, we know the tangent of 2 pi over 3, right? Well, 2 pi over 3, let's talk about the unit circle. And the unit circle, we got a angle 2 pi over 3, that's our 60-degree mark in quad 2, pi minus pi over 3, which has a x-coordinate of negative 1/2 and a y-coordinate of square root of 3 over 2. So we're talking about tangent, right? Tangent of 2 pi over 3. That's equal to, again, y-coordinate of x-coordinate. That's equal to square root of 3 over 2 divided by negative 1/2, which is square root of 3 over 2 times negative 2 over 1, which is equal to negative square root of 3. So there's the tangent of 2 pi over 3. Tangent of 2 pi over 3 equals negative square root of 3. So back to our equation, right, we can plug that in. So that's negative square root of 3 equal to y divided by x. As we want to get it in graphing form, we could multiply both sides of this equation by x. Right? As we do that, we come up with an equation that reads y equal to negative square root of 3x. Right? So there's our rectangular equation, right? And the polar equation. So just doing some conversions. So that page, again, going from polar to rectangular with ordered pairs, right? And then with equations also.